Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗚𝗟𝗟 and today I'm gonna showcase the challenge I've made for HTBOO 2025. And let's start with tool gathering. So we download the file and unzip it, and we have a readme.txt and the tool gathering binary. So let's read it, and we see tips from 𝗪𝗚𝗟𝗟, how to run the program locally and how to run it remotely. And then we have some hints. It says 3 values to pack, random each time, just p64 them and go. So let's run the program. We see that we got the 𝗧𝗟𝗟𝗍𝗪 address this time. Let's say we have 𝗪𝗚𝗟𝗟 here, and it says bad choice, and this is 𝗪𝗚𝗟𝗟 in hex, and the correct is 𝗧𝗟𝗟𝗍𝗪. So if we run it again, okay, we were unlucky, 𝗧𝗪 again, let's try another time. Now we see that we got the 𝗧𝗟𝗟𝗍𝗪 address. So this is what we're gonna do. We have to loop this 3 times, read this address, p64 it and send it back to the program. And let's start crafting our payload. Vim solver.py from pon import all, and then we need def name to be val, and then we're gonna create a local process like this. And for the remote instance you will need something like this, IP and port. And now for in range 3, because we need it 3 times, we're gonna r.rec until receive until this string, read junk lines, and then our address should be r.rec line, and we want to strip the new lines from that. And we also need to convert it to integer because it's from base 16. So this is the command. We take the address in hex value and we convert it from base 16 to an integer. And last we need to send this our send line p64 and our address, and this shall give us the flag hopefully. Oh, this is not val, this is tool gathering. And this one did not work. Why? Because here we are sending 8 bytes and the program ends when it reads 8 bytes, so we don't need to send the line here. We need to just send this like this. And as you can see, we actually managed to get cell ls, and if we try to do it remotely, we simply go here, change this to our IP and port, which in my case are localhost and lit. And again we see that we managed to get cell. So that was the first challenge. Let's go to the second one. We are here with handler test. Let's unzip the file. And again cat readme, and we see rank the program locally, handler test, the same. And the hints: option 1, ring the alarm, just give it 5 secs. Option 2, smash the stack, overflow the buffer. Option 3, all divisions are acceptable. No, and it has a division by 0. And okay, we see cat flag 1, 2 and 3. So we see that the flag is split into 3 sub flags like this, and let's run it. Okay, we have 4 options. Let's go with 1. It says just wait 5 secs. Let's see. And it says you triggered a SIG alarm, countdown complete, here's your prize, and we get the first part of the flag. And if we do it again, smash the stack, please enter payload. So let's try and smash the stack. You managed to trigger a SIG signal, here's your prize, and we get the second part of the flag. And last, option 3. Enter 2 numbers, let's say 69 and then 0. And we see that we triggered the last exception and got the last part of the flag. So the challenge was actually this. You had to trigger 3 handlers First of all, the alarm, then the 𝗙𝗟𝗙𝗙 for segmentation fault and buffer overflows, and the third one was the float point exception error, which can be triggered from any legal division like divide with 0. And let's go for the third challenge, and we are at Abnormaleak. Let's try and unzip it. Again, cat readme. And again the tips, and we see option 1 reads a file flag on the stack, option 2 prints data, maybe the flag, without a formatter, so this is probably a format string vulnerability. Option 3, you can write data and abuse the format string. And another hint, the flag starts with HTB and curly bracket, whose hex values are 0x48, 54, 42 and 7b, and the program prints the data in little endian reverse order. Okay, so let's take a look at the program. We have Abnormaleak, and then we see we have a download data, boom, data parsed successfully, nothing we can see. And let's try and print that. It says it's empty, and write, enter data, data written, and the program exit. Let's take a look inside the decompiler. So we start from main here, and let's make it, it's already sudo C, and we go down, and we have our counter I, and then our choice here. So this is our choice. With option 1, we see that it opens flag.txt, so this is saved on the stack. If option is 3, we can actually write data. We see here we have a read function, and option 2 right here we see printf, and this without a formatting. That means we can abuse the format string vulnerability. If you don't know what this is, I have made some videos explaining it, or you can see the write-up on the GitHub. So let's go and try to abuse it. So we run the program again, and let's see, download data and write data, and we're gonna do %p, %p, blah blah blah, and then print data, and we actually see that we managed to leak something. If we print more and more and more data, we'll eventually print the flag. So let's try and leak the flag this way. Again, we have download data and then write data. And we see that we have managed to leak some stuff, and as the hint said, cat readme, we know that we need to find the values 48, 54, 42 and 7b. So let's see if we can find them here. So let's try and taking this until let's say until this address. So we copy it and we go to 𝗙𝗟𝗟𝗪. I have also made an automated solver, you can see it on GitHub, but right now there's no need to write a solver. You can see it from here, and you take our input, and here from hex, boom, and we also need it reversed, so reverse if you take them in the correct order. And if we rearrange them like this, you see that you can get HTTP fake flag for testing, which is actually our flag. So you're gonna do the same for the remote instance and get the actual flag. And let's head to the next challenge. We're inside rookie mistake and cat readme, run the program locally, blah blah blah, hints, not so simple ready to win challenge, overflow the buffer and call win or a certain address of it. Okay, so let's see our challenge here, rookie mistake, rook, my beloved hunter, align the course, escape, so okay. Will you manage to call the current escape? And we see that we got an actual segmentation fault. That's really nice. And let's go inside the debugger, 𝗙𝗟𝗟𝗪, and we see that there is no canary. That means we can easily abuse a buffer overflow, and no pi. That means we can exploit techniques like writeup, ready to win, or whatever. And let's see info functions. We see we have some custom functions here. Let's take a look at overflow core. And that's nice. Here we see that there are some checks. Okay, cool. And in the end there is a system, which is really nice. And system actually calls this, which is XS. Okay, so this actually calls system bin_sh. The tricky part here is that if you go to simply ready to win, as a win we have overflow core. If we start here, the challenge will start and checking stuff. Check core, so it will check some of the registers if they are correct, and you see that it has 5 cores, and believe me, you're not gonna be able to abuse that. You have no control of these registers, so you simply have to go here and just load bin_sh and simply call system. So we run the program again and stop, cyclic 100, and we take this continue and insert that, and we see that the program crashed at this address. So we see the RIP is at 66. So we're gonna take RBP and add 8 to that, and cyclic -0, this, it's 32 plus 8, so the offset we found is 40. And after that what we need is this as overflow core, and we actually need to hit this address right here to 30. From pawn import all, and fname shall be rookie mistake, and for the local process we're gonna have fname here, and later on we're gonna have this for our remote instance. And we also need this time to analyze the binary and take all the addresses. So we're gonna e equals elf fname and r.sendLine, and we have our a's times, what was it, 40 plus p64, because we need to pack the addresses of e.sim overflow core, and the offset that we're gonna call system.bin.sh is at 230. And after that, if we r.interactive, we shall get cell. So let's see, Python solver, and we see that we actually managed to get cell locally. And let's try this also remotely. So vim solver, and here we just comment this and comment this, and we see that we actually managed to get cell on the remote instance as well. And let's go for the last challenge. Last but not least, we have rookie salvation, and let's run cat readme first. And we see, just let it free. 0x dead beef, nah, wethans is better. How much to allocate? 20, 0x20, 0x a lot. Where is the offset to overwrite? Escape. Okay, so let's run the program. The road to salvation is closed, so obliterate. Okay, we got no output here. And reserve space, space to reserve 100. Message for Nemegast, wethans. Obliterate. Okay, double free detected, so actually option 2 frees something. And let's go inside binary ninja and see what happens to the program. We start from main, and we see that there is an allocated space with malloc 0x26. Okay, the allocated space plus 0x1e has the value dead beef. That's nice, and this is our choice here. So with option 3 we go to road to salvation, and right here it checks if the allocated space plus 0x1e, which is the dead beef value, contains wet hands instead, it will give us the flag right here, otherwise it will exit with fail. Okay, so our goal is pretty much straightforward. We need to overwrite dead beef in the allocated space plus 0x1e with wet hands. And how we're gonna do that? Let's see what else we have. We have obliterate, which actually frees the allocated space. And then we have reserve space, which has this as the size, and then it mallocs our size here. Let's say this is the address we write, and then we write to this address. Okay, this is how the program works. Let's see inside the debugger to get a better look. And gdb rookie salvation, b main, and we run the program, continue. So right now, if we take a look at the heap, we see that the value dead beef is right here. We continue, let's free it, and again take a look at the heap, and we see that the value is still here, so something is wrong with the program. And we see that the TCAS points at this address here. As we saw, the challenge allocated 0x26, so 0x26 is 38, so it allocated 38 bytes to write this string, and we're gonna abuse this use after free. So we're gonna allocate the same space, 38, and the program, instead of writing in another chunk, it will reuse what chunk TCAS has right here. So let's say continue and send option 1, and the size will be 38, and then message we have AAAAA, BBBB, CCCC, DDDD.
These nuts! Got him!
Take a look at the heap again, and we see that we start overriding here. This is our string and this is deadbeef. So in this case, what we actually need to do is calculate the offset, which is already known, it's 0x1e, and after that, we should start writing 𝗪𝗧𝗪 above deadbeef. Let's go and craft our payload. I already have a template ready, so we fname the challenge, context lock level critical, process remote, and here we're gonna have obliterate -3. So r.sendLine after, and right here it was this, and option 2 bytes to avoid errors, and then allocate space. So we're gonna have r.sendLine after, and here we're gonna have this and option 1, and then r.sendLine after this, and this is gonna be the size. So we're gonna use just in case I'm gonna use this, and encode to avoid warnings, and r.sendLine after again this. We're gonna have our payload, which is, let's say, 8 times 0x1e, as we saw the allocated memory offset, plus the string 𝗪𝗪𝗪, and then escape r.sendLine after, and here we're gonna have this, and hopefully this will give us the flag. Let's go, Python solver, sendLine after. Okay, I made a mistake, send line after, and we see that we have managed to get the flag this way. And if you do the same for the remote instance, you'll also get the flag there. So this was a challenge I made for HTBOO 2025. I hope they were enjoyable and you learned something from it. If you have any questions, you can leave a comment or send me a DM in Discord. And if you want to support me, leave a like and subscribe to the channel for more. Thank you guys for watching, have fun, and see you in the next videos. Bye.